Several of the students have shifted from this section to other section. Can this come down? Huh? Right. They have given up on their own, or have you made them give up? Okay. So did you try the questions yesterday? Yes. What about here? Boys? Try ಮಾಡಿದ್ರಾ? Many times what happens, several students starting ಅಲ್ಲಿ ಏನು ಇಂಟ್ರೆಸ್ಟ್ ತೋರ್ಸಂಗಿಲ್ಲ. They are taking it like fun and games, ಆಟ ಆಡ್ಕೊಂತ ನಕ್ಕೊಂತ ಓದ್ಕೊಂತ ಓಡಾಡ್ಕೊಂತ ರೈಟ್ ಆರಾಮಾಗಿ ಏನಪ್ಪ ಎಕ್ಸಾಮ್ ಇನ್ನ ಒಂದು ವರ್ಷ ಆದ್ಮೇಲೆ ಏನ್ ಇವತ್ತೇ ಓದ್ಲಿಲ್ಲ ಅಂದ್ರೆ ಏನ್ ಆಗಂಗಿಲ್ಲ. ನಾವು ಒಂದು ವರ್ಷ ಆದ್ಮೇಲೆ ಎಕ್ಸಾಮ್ಕಿನ್ನ ಹಿಂದಿನ ದಿವಸ ಓದೇ ಫುಲ್. And it's not just this year, every year. But several students who we think that they should do well and we put them in a good section and then we try and give them everything, their attitude is at the start, sir ಹೆಂಗಾರ ಮಾಡಲಿ ಏನಾದರೂ ಮಾಡಲಿ ನಾವು ಏನು ಮಾಡೋದು ಅದು ನಾವು ಮಾಡ್ತೀವಿ. ಎಕ್ಸಾಮ್ ಬರ್ತಾ ಬರ್ತಾ ಹೆಂಗನಾಗಲಿ ಎಕ್ಸಾಮ್ ಏನಾರ ಆಗಲಿ ಇಲ್ಲ, ಆಮೇಲೆ ರಿಸಲ್ಟ್ ಬಂದ್ಮೇಲೆ ಎಲ್ಲ ಪೇರೆಂಟ್ಸ್ ಬಂದು ಅಳ್ಕೊಂಡು ಕುಂತಿರ್ತಾರೆ. ದಾಟ್ ಆಲ್ಸೋ ಅವ್ರಿಗೆ ಮನಸ್ಸಿಗೆ ಹತ್ತಂಗಿಲ್ಲ. ಅಳ್ತಾರ ಕೆಲಸ ಅವ್ರದ್ದು, ಅಪ್ಪ ಏನು ಅಷ್ಟು ರೊಕ್ಕ ಕಟ್ಟನ ಅದಕ್ಕೆ ಬಂದಿಲ್ಲ ಅಂತ ಹೇಳ್ತಾನ ಅಂತ. I mean, that far away attitude do you have? Or some students are like, okay, at that time they see their parents crying, they see that students who were weaker than them have scored better than them. At that time they start feeling like, no, I should have worked. ಅವಾಗ ಫೀಲಿಂಗ್ ಬಂದ್ಮೇಲೆ ಏನು ಮಾಡಕ್ ಬರಂಗಿಲ್ಲ. ಅದಕ್ಕೆ ನಾನು ಮೊದಲಿಂದಾನೇ ಹೇಳ್ತಾ ಇದ್ದೀನಿ, ಎವ್ರಿ ಡೇ ಎವ್ರಿ ಮಿನಿಟ್ ರೈಟ್ ನಾವು ಜಸ್ಟ್ ಸ್ಪೆಂಡ್ and concentrate towards studies. Only then ಏನಾದರೂ ಇಂಪ್ರೂವ್ಮೆಂಟ್ ಇರುತ್ತೆ. And I'm saying this, right? No need to do it overnight, just every day. ನಿನ್ನೆ ಒಂದು 2 ತಾಸು ಓದಿದ್ರೆ ಟುಡೇ ಸ್ಟಡಿ 2 hours 5 minutes. ನಿನ್ನೆ 2 ತಾಸು ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಿದ್ರೆ ಇವತ್ತು 2 ತಾಸು 5 ನಿಮಿಷ. ಎವ್ರಿ ಡೇ ಒಂದು 5, 10, 15, 20 minutes ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ಕೊಂತ ಹೋಗ್ರಿ. ಎಸ್, ಟ್ರೈ ಟು ರೆಡ್ಯೂಸ್ distractions. Yes, whatever discussions you are doing, all discussions try and keep it related to the subject. You've been writing exams every week. Some of you are scoring very low, some of you are scoring good, but still the scores are not satisfactory. Nobody is scoring 600 plus in Neet. Somebody is scoring around 300 in JEE. ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ ನಿಮ್ಮ ಲೆವೆಲ್ ಎಲ್ಲಿದೆ, ಇನ್ನು ನೀವು ಎಷ್ಟು ಕಷ್ಟಪಡಬೇಕು, ಇನ್ನು ಎಷ್ಟು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಬೇಕು ಅನ್ನೋದನ್ನ. ಅದು ಅರ್ಥ ಆದರೂ ಕೂಡ ಮಾಡ್ತಾ ಇಲ್ಲ ಅಂದರೆ somewhere, I mean, either we are not strict enough or even or you are not serious enough. Yes, how do we solve this? Tell me. For every student, should we have a teacher assigned so that every minute the teacher spends with them, the student, and then ಈ ಕಡೆ ನೋಡಿದ್ರೆ ತಲೆ ಹೊಡೆದ, ಈ ಕಡೆ ನೋಡಿದ್ರೆ ತಲೆ ಹೊಡೆದ, ಈ ಕಡೆ ನೋಡಿದ್ರೆ ತಲೆ ಹೊಡೆದ, ಹಂಗೆ ಮಾಡಬೇಕಾ? ಬೆಸ್ಟ್ ಅಲ್ಲ ಅದು? ಹಾಂ, ಅಷ್ಟು ಸ್ಟ್ರಿಕ್ಟ್ ಆಗಿ ಮಾಡಿದ್ದಕ್ಕೆ ಏನೋ ದಿ ಅಮೌಂಟ್ ಆಫ್ ಸ್ಟೂಡೆಂಟ್ಸ್ ಹೂ ಆರ್ ಅಂಡರ್ ಸ್ಟ್ರೆಸ್ has increased by a lot. ಸೊ ಕೋಟಾದಲ್ಲಿ ಅಲ್ಲಿ ಏನು ಮಾಡ್ತಾ ಇದ್ದಾರೆ, ಫ್ಯಾನಿಗೆ ಸ್ಪ್ರಿಂಗ್ ಆಗ್ತಾ ಇದ್ದಾರೆ. ಅಷ್ಟು ಪ್ರೆಷರ್ ಹಾಕಿದ್ರೆ ಹುಡುಗರಿಗೆ ಇದರ ಮೇಲೆ ಹೋಗ್ತಾರೆ ಇವ್ರು ಬೇಡಪ್ಪ ಅಂತ ಹೇಳಿ ಫ್ಯಾನಿಗೆ ಸ್ಪ್ರಿಂಗ್ಸ್ ಆಗ್ತಾ ಇದ್ದಾರೆ, ಅಥವಾ ಫ್ಯಾನ್ ತೆಗೆದು ಟೇಬಲ್ ಫ್ಯಾನ್ ಇಡ್ತಾ ಇದ್ದಾರೆ. ಎವ್ರಿ ಮಾರ್ನಿಂಗ್ ಯಾರಾದ್ರೂ ಒಬ್ರು ಇದನ್ನೇ ಲೇವ ಇದನ್ನ ಅಂತ ವಾರ್ಡನ್ಸ್ ರೂಮಿಗೆ ಹೋಗಿ ನೋಡ್ತಾ ಇದ್ದಾರೆ. ಆ ಥರ ಅಂತೂ ಪ್ರೆಷರ್ ಇಲ್ಲ. ನಿಮ್ಮ ಒಳಗಡೆಯಿಂದನೇ ಬಂತು ಅಂದರೆ ಅದು ಥರ ಬೇರೆ ರಿಸಲ್ಟ್ ಕೊಡುತ್ತೆ. ಇಫ್ ನಾಟ್ ನಾವು ಅಟ್ಲೀಸ್ಟ್ ಆಫ್ಟರ್ ಸಮ್ ಟೈಮ್ ಅದು ಇರಬೇಕು ಒಂದು ಸ್ವಲ್ಪ. Other students or other teachers are not motivating you enough, or is the thing that you are doing very easy? Should we try and level it up, make it very difficult so that you understand nothing? ಅದರದೊಂದು ಮತ್ತೆ ಬೇರೆ ಪ್ರಾಬ್ಲಮ್. ಚಲೋ ಹೇಳಿದ್ರು ಅರ್ಥ ಆಗಿಲ್ಲ ಅಂದ್ರೂ, ಈ ಅರ್ಥ ಆಗಂಗೆ ಹೇಳಿದ್ರು ಇದು ಈಸಿ ಆಗಲ್ಲಪ್ಪ ಅಂತ, ಅದೊಂದು ಬೇರೆ ಪ್ರಾಬ್ಲಮ್. ಎಸ್ ಏನ ಚಲೋ ಹೇಳಿದ್ರೆ, ಅರ್ಥ ಆಗಂಗೆ ಹೇಳಿದ್ರೆ ಇದೇನು ಈಸಿ ಅದ ಬಿಡು ಅಂತ ಬಿಟ್ಬಿಡ್ತಾರೆ. ಸ್ವಲ್ಪ ಡಿಫಿಕಲ್ಟ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದ್ರೆ ಇದೇನು ಬಿಡು ಅಂತ ಬಿಟ್ಬಿಡ್ತಾರೆ. ಬಿಡೋದಂತರೂ ಎರಡೂ ಪಕ್ಕ. ಮತ್ತೆ ಯಾಕಂದ್ರೆ ಬರ್ತಾರೆ ಸುಮ್ಮನೆ ಬಿಟ್ಟೇ ಬಿಡ್ರಲ್ಲ. How many of you sincerely tried 2 questions? Just 2 questions are given for me. How many of you tried? Yes. Reflect it. ನೀವು ಅನಿಸ್ಬೇಕು ಅವ್ರು ಮಾಡಿದಾರ ಅಂದ್ರೂ ಅವ್ರು ಎಕ್ಸಾಮ್ ಮಾರ್ಕ್ಸ್ ಬರ್ತಾ ಇಲ್ಲ, ಏನು ಮಾಡಿದ್ರೆ ನ್ಯೂಸ್ ಇಲ್ಲ ಅಂತ. ನಾನು ಮಾಡಲಾರ್ದೇನೆ ಬರ್ತಾ ಇಲ್ಲ ನನಗೆ ಮಾರ್ಕ್ಸ್ ಈಗ ಭಾಳಷ್ಟು ಮಂದಿಯಲ್ಲಿ ಅದನ್ನು ಫೀಲಿಂಗ್ ಬರ್ತದೆ. ಬಟ್ ಅಟ್ ದಿ ಎಂಡ್ ಆಫ್ ದ ಡೇ ಯು ವಿಲ್ ಸಿ ದಟ್ ಯಾರು ಸಿನ್ಸಿಯರ್ಲಿ ಮಾಡ್ತಾ ಇದ್ದಾರೋ ಅವರು 2 years ಇವಾಗ ಕಡಿಮೆ ಬಂದ್ರೂ ಆಮೇಲೆ ಅವರಿಗೆ ಒಂದೇ ಸರ್ತಿ ಶೂಟ್ ಆಗುತ್ತೆ. People who think of taking shortcuts, people who think that no, everything will work out for me without putting in efforts. ಆಮೇಲೆ ಯಾವಾಗ ಅದು ಕಾಲಿಂದ ಕುಸ್ತು ಒಳಗೆ ಬಿಡ್ತೀರಿ ಗೊತ್ತೇ ಆಗಂಗಿಲ್ಲ. ಸ್ವಲ್ಪ 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 ಸ್ಟ್ರಾಂಗ್ ಮಾಡ್ಕೊತ ಬರ್ರಿ. ಸ್ವಲ್ಪ 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 ಸೀರಿಯಸ್ ಆಗ್ರಿ. Already the world is going somewhere in every direction, in every place, in every level, is going bad. Yes or no? ಯಾವ ಎಕ್ಸಾಮ್ ಬರೆದ್ರೆ ಆ ಎಕ್ಸಾಮ್ ಲೀಕ್ ಆಗಂಗಿಲ್ಲ ಅಂತ ಇಲ್ಲ. ಏನು ಕೆಲಸ ಮಾಡೋಕೆ ಹೋದ್ರೆ ಅಲ್ಲಿ ಏನು ಕೇಳಂಗಿಲ್ಲ ಅಂತ ಇಲ್ಲ. ಸುಮ್ಮನೆ ನಮ್ಮಷ್ಟೇ ನಾವು ಇರ್ತೀವಿ ಅಂದ್ರೂ ಬಿಡಂಗಿಲ್ಲ. It is becoming very, very difficult outside. No? Right now you are in this small, wonderful bubble that okay, ನಾನು ಇದು ಓದಬೇಕು, ಇದಾದ್ಮೇಲೆ ಇದು ಬರೀಬೇಕು. ಮುಂದೆ ಹೊರಗಡೆ ಹೋದ್ಮೇಲೆ going to become very difficult. Yes. Okay, fine. So what do we have here? The first question from work is the solid contains 5 into 10 power 21 atoms. If one electron is removed from each of how much? 0.01% of the atoms, find the charge gained by this solid. Okay. When the neutral atom ಇದೆ ಅಥವಾ ಅದರಲ್ಲಿಂದ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ತೆಗೆದ್ರೆ it will gain positive charge or negative charge. As a neutral atom, if you remove an electron, it will gain a positive charge and it will gain a positive charge. Sign about the positive charges. Now, which formula you use here if you want to calculate a charge on any object? We will use quantization of charge where Q is equal to plus or minus N into E. E already you know here, the only thing you have to calculate is what is the value of N. Okay, so this is plus N into E. For N, how many number of atoms are there? If all atoms in the electron ತೆಗೆದಿರಾ? Is one electron removed from all of these atoms? If one electron is removed from all of these atoms, how many electrons will be removed? 5 into 10 power 21. Yes, sir. One atom ge one electron ತೆಗೆದ್ರೆ total number of atoms is 5 into 10 power 21. So total electrons removed is 5 into 10 power 21. But is the electron removed from all the atoms? No. What does it say? Electron is removed only from 0.01% of this many. So ಎಲ್ಲ ಇದರಿಂದ ತೆಗೆದರೆ ಎಷ್ಟು? 0.01% ಇಂದ ತೆಗೆದರೆ ಎಷ್ಟು ಬರುತ್ತೆ? This multiplied by 0.01%. Therefore n ಏನು ಬರುತ್ತೆ? N will be 0.1% of how much? 5 into 10 power 21. How much is this? 0.01% ಅಂದರೆ 0.01 divided by 100 into 5 into 10 raised to. So this is 10 power minus 4. Yes, 10 power minus 4 into 10 power 21 will be 10 power 17. Yes, 10 power 17. So therefore n will be equal to how much? N will be equal to 5 into 10 power 17. This is number of electrons removed. So therefore Q will become how much? Yes, 5 into 10 power 17 multiplied by E. E is 1.6 to 10 power minus 19. Q is coming out to be 16 5 are 88. 8 into 10 power minus 2. Okay. So this 8 into 10 power minus 2. Is that fine? Yes. So what was so difficult about this? Again, some attitude of the students is this that okay, on 5 questions homework ಕೊಟ್ಟರೆ ಅದರಲ್ಲಿ ಯಾವುದೋ ಒಂದು ಕ್ವೆಶ್ಚನ್ ಭಾಳ ಡಿಫಿಕಲ್ಟ್ ಇರುತ್ತೆ, ಅದರ ಮೇಲೆನೇ ಫೋಕಸ್ ಮಾಡಿ ಉಳಿಕೆದ 4 ಮಾಡೋದು ಬಿಟ್ಟು. Yes, don't do that. I mean, if you are able to do 4, do those 4. 5 is something you are not able to do just by trying. That also is a good thing. Because you can focus on difficult questions only when you are practicing. During the examination, ಬರ್ತಾ ಇಲ್ಲ ಅಂದ್ರೆ ಬಿಟ್ಬಿಡೋದೇ ಬೆಟರ್. Is it fine? Okay. A copper sphere contains about 12 to 10 power 22 atoms. The charge on the nucleus of each atom is plus 29 E. what fraction of electrons must be removed from the sphere to give it a charge of how much? 2 microcoulomb. Give it a charge of 2 microcoulomb. Okay. So for plus 2 microcoulomb charge, what will be the value of n? Let us calculate that first. Q is equal to, let's say, plus 2 microcoulomb. So that should be plus 2. What should be the value of n? N into E. Implies n is equal to 2 into 10 power minus 6 divided by 1.6 into 10 power minus 19. How much is this coming out to be? 20 by 16 into 10 power 13 is 20 by 16 into 10 power 13. 4 20, 4 4s are 16. Now again you make it as 5 into 100 divided by 4 to 10 power 11. So this 10 power 13 I will write it as 100 into 10 power 11. So and then 125. Okay, the value of n is coming out to be 125 into 10 power 11. ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ತೆಗೆದ್ರೆ ಚಾರ್ಜ್ ಏನು ಬರುತ್ತೆ? ಪ್ಲಸ್ 2 micro. What are the total number of electrons in this copper sphere? Can you tell me what will be the total number of electrons? One copper sphere ಅಲ್ಲಿ one copper atom ಅಲ್ಲಿ ಎಷ್ಟು ಇರುತ್ತೆ? How many electrons? Are you able to decide how many electrons? Can you look at this? The charge on the nucleus of each atom is how much? 29 E plus 29 E plus 29 E. Nucleus ಗೆ charge ಆಗ್ತಿರುತ್ತೆ because nucleus contains protons, right? So plus 29 E charge ಇದೆ ಅಂದ್ರೆ how many protons are there? 29. So for any copper atom, if it has 29 protons, it should also have 29 electrons. Yes, sir. Okay. So each copper atom has how many electrons? It has 29 electrons. So therefore, these many atoms you have. How many atoms you have in this copper sphere? 2 into 10 power 22 atoms. Therefore, total number of electrons estaಗುತ್ತೆ? Total number of electrons estaಗುತ್ತೆ? Total number of electrons will be 2 into 10 power 22 multiplied by 29. Yes, sir. This is 58 into 10 power 22. We have a copper sphere. Okay, that copper sphere has how many copper atoms? 2 into 10 power 22 copper atoms. Okay, now what they are saying is this copper is converted into a charged object. Charge ಎಷ್ಟು? 2 microcoulomb. So 2 microcoulomb charge ಬರಬೇಕು ಅಂದ್ರೆ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ ತೆಗಿಬೇಕು? ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ ತೆಗಿಬೇಕು? How many electrons should we remove? You have to remove 125 into 10 power 11 electrons. Now, how many total number of electrons are there? 58 into 10 power 22. What is the question asked? The question asked this: what is the fraction of electrons that must be removed from the sphere? Fraction ಅಂದ್ರೆ ಏನು? ಎಷ್ಟು remove ಮಾಡಿದರ divided by ಎಷ್ಟು ಇದೆ? So how many you have removed divided by how many actually are there? Therefore, fraction equal to electrons removed divided by total total electrons present. Let's start with the electrons removed is how much? Electrons removed is 125 into 10 power 11 divided by how many electrons are present? 58 into 10 power 22. So this is coming out to be 2 point. This is 2 point. Yes. One 25 divided by 2.1. ಆಗುತ್ತೆ ಇದು. Any doubts in this? Did you understand the logic of charging? Yes. If you have an atom, neutral atom, if you remove one electron from it, what is the charge of the object? The charge on the object will be E, right? Plus E, right? If you remove one electron from this object, the charge on the object will be E. If I remove 100 electrons from the object, what will be the charge on the object? 100 E. If I remove 10 power 22 electrons from the object, what will be the charge on the object? 10 power 22 E. Plus irutta, minus irutta? Plus. Adhe one object is a neutral object. If I add electron to it, right? So if I add one electron, what will be the charge? Minus E. If I add 100 electrons, it will be minus 100 E. So when they are saying that the charge is 2 microcoulomb, what does it mean? Or the charge is plus 2 microcoulomb. Plus 2 microcoulomb in the n value ಏನು ಬರ್ತಾ ಇದೆ? 125 into 10 power minus 11. So what does this n value indicate? Number of electrons which are removed from it. So if this charge was minus 2 microcoulomb, this n would represent how many electrons were added. So removed andre it has less electrons as compared to before. Yes, it has less electrons as compared to before. So electrons are in excess or electrons are in short. Now if it is minus 2 microcoulomb, okay, it is minus 2 microcoulomb, then it has electrons in excess or it has electrons in short? It has electrons in excess. Okay, so excess and short, this is also another way of asking how many number of electrons are removed or how many number of electrons are added. Okay. Finish? Yes? Now why are we studying about charges? Because we want to learn charges exert a particular kind of force on each other. Okay, so that particular kind of force is called as electrostatic force. So electrostatic force value yav tara calculate ಮಾಡಬಹುದು, right? We have learnt in gravitation is if you have two masses, how do you calculate the force between two masses? G m1 m2 divided by r square. Okay, so for charges also there is a very similar formula, okay, called k q1 q2 by r square. Okay, so there gravitationally force depends on product of mass in the numerator and it is inversely proportional to square of distance. Here also similarly, there it was called as Newton's law of gravitation. Here it is called as Coulomb's law, because Coulomb was the person who gave this law on how to calculate force between 2-point charges. Okay. Force between 2-point charges ಯಾವ ತರ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ it depends on the product of charges and it is inversely proportional to square of distance between them. Many things about gravitational force and electrostatic force are similar. Okay. Please write on Coulomb's law, also called as inverse square law for charges. Inverse square law yakantivi andre because it varies as 1 by r square. Force between 2-point charges varies as inversely as square of distance between the charges and is directly proportional to the product of magnitude of two charges and acts along the line joining the 2-point charges. There are three essential things here. Inversely as a square of the distance between the charges. First essential point and directly proportional to the magnitude. Here it is the magnitude of essential point. The third one is, what does it act? Acts on the line joining 2-point charge. So how was the biology class? Saturday and Sunday. Neelima madam. They took principles of inherited genetics, right? And human physiology. Human physiology of muscles. Huh? Right? Counter current. Okay. Counter current in? Okay, nervous system. Respiratory system. Excretory system. Okay. Fine. So, what does it say? First of all, actually Coulomb's law talks about force between 2-point charges. Like how Newton's law of gravitation talked about force between 2-point objects. Okay, it talks about force between 2-point charges. Now we have already seen what is a point charge. Yes, point charge. Effect ಬಗ್ಗೆ ಮಾತಾಡ್ತೀವಿ, dimension ಬಗ್ಗೆ ಮಾತಾಡೋಣ. Right? Let's say you have these 2-point charges Q1, Q2. Okay. Now, what does it say? Starting from the third point, it says that it acts along the line joining these two point charges. So how do you draw the line joining these two charges? Let's say this is the line joining these two. Now, one of the properties of charges is if they are similar charge between both of these charges, ಯಾವ ತರ force ಇರುತ್ತೆ? Attraction or repulsion? Repulsion. Okay. Now, how do you show repulsion? Okay. Now this Q1 will exert a repulsive force on Q2. So repulsive, this force has to act along this line, right? So there are only two choices. That force, either it has to be towards right or it has to be towards, which direction will it be? Will it be towards right or will it be towards? The Q1 is repelling Q2, then repulsion direction in agate, repulsion direction away agate, it will be towards away, right? So similarly, Q2 will do what? Q2 will also exert a repulsive force on Q1. Okay. So repulsive force on Q1 ಅಂದರೆ ಯಾವ ತರ ತೋರಿಸಬಹುದು? So repulsive force between 2 point charges is shown like this, whereas attractive force between 2 point charges, let's say this is a positive charge Q1 and this is a negative charge, and the line joining these two is. So if this is the line joining Q1 and Q2, how do you show attractive force? Yes, attractive force. How do you calculate this force? Yes, what does it say? This force is proportional to what? Magnitude of product of charges. Yes, this force is proportional to magnitude of product of charges. And then this force is inversely proportional to square of the distance between them. Let's say this distance between them is, so combining these two, what you get is, you get that force is actually proportional to and if you remove proportionality constant, you get F is equal to K what is this K? So K is actually equal to 1 by 4 pi. Please note this down here. So whatever F I'm drawing here, I'm calculating what? Magnitude of the force. Okay. So direction is drawn like this. Okay. Magnitude is calculated like this. K Q1 Q2 by R square. Now similar to vector form in gravitational force, here also you have a vector form. You will write that vector form sometime. Okay, so gravitationally, that force, gravitation, you wrote it as G m1 m2 divided by R square, and this G itself was a constant called as the universal gravitational constant, whereas in this, when you replace this proportionality constant, proportionality sign with the proportionality constant, the F is equal to K Q1 Q2 by R square, this K is further written as 1 by 4 pi 7. Either 4 pi is constant. What is this epsilon? Epsilon is actually called as what? Epsilon is called as permittivity of medium. Epsilon is called as permittivity of medium. What was the need to convert this K into another constant as 1 by 4 pi epsilon? because what happens is electrostatic force depends on medium. Say you have the same Q1 and Q2. Okay, if it is in air, the force between them is different as compared to when both of them are placed in some other medium like water, or if they are placed in some other medium or in between glass. Okay. So very medium only Q1 Q2 it again the force between these two changes. So therefore there was a need to convert this K into 1 by 4 pi epsilon and introduce this constant called as permittivity of medium. Okay. So this permittivity of medium, for air it has a different value, and for glass it has a different value, and for conductors this has a different value. Okay. So for air or okay, ಮೂರು ಒಂದೇ, air ಅಂದ್ರೂ ಒಂದೇ, vacuum ಅಂದ್ರೂ ಒಂದೇ, free space ಅಂದ್ರೂ ಒಂದೇ, all of these three are used synonymously, and the value of K will be equal to 9 into 10 power 9. The value of K will be equal to 9 into 10 power 9, and the unit of this K will be Newton meter square per. The value of this K is Newton meter square per square. The K value is epsilon actually value ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ epsilon naught ಅಂತ ಕರೀತಾರೆ. This epsilon naught will be equal to 8.85 into 10 power minus 12. Okay. So force between any two point charges, magnitude was calculated as K Q1 Q2 by R square. Specifically for air or vacuum, the value of K is taken as 9 into 10 power 9. Okay. Or for air or vacuum, if you want to write K as 1 by 4 pi epsilon, instead of epsilon what you will use is, you will use it as epsilon naught. Okay. The value of epsilon naught is taken as 8.85 into 10 power minus 12. Okay, done. Okay. Electrostatic force. What kind of force? Okay. Now, some of the properties of electrostatic force, as is the case with gravitational force, electrostatic force is also a central force. Gravitational force in it is also a central force. Or did we conclude that it is a central force? If you take two objects, right? If you take two objects like this, the force of gravitation acts along the line joining the center of mass. So if you have two large objects, ಅವೆರಡು ಲಾರ್ಜ್ ಆಬ್ಜೆಕ್ಟ್ ನಡುವರ್ಕ ಗ್ರಾವಿಟೇಷನಲ್ ಫೋರ್ಸ್ ಯಾವ ತರ ಇರುತ್ತೆ ಅಂದ್ರೆ ಇಟ್ ವಿಸ್ ಆಕ್ಟಿಂಗ್ ಅಲಾಂಗ್ ದ ಲೈನ್ ಜಾಯಿನಿಂಗ್ ದಿ ಸೆಂಟರ್ ಆಫ್ ಮಾಸ್. ಅದೇ ತರ ಇಲ್ಲೂ ಕೂಡ ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಫೋರ್ಸ್ acts along the line joining the points, so it is a central force. Okay. Then electrostatic force is a conservative force. Okay, Similar to gravitational force, electrostatic force is also a conservative force. Conservative force ಅಂದ್ರೆ ಏನು? ಯಾವುದೇ ಫೋರ್ಸ್ ನ ಕನ್ಸರ್ವೇಟಿವ್ ಅಂತ ಕರಿಬೇಕು ಅಂದ್ರೆ ವರ್ಕ್ ಡನ್ ಬೈ ದಟ್ ಕನ್ಸರ್ವೇಟಿವ್ ಫೋರ್ಸ್ ಇನ್ ಅ ಕ್ಲೋಸ್ಡ್ ಲೂಪ್ ಇಸ್ zero or work done is independent of path. Work done is independent of path. If you go by this path or if you go by this path, if the starting and the ending points are same, the work done will be same. Okay. Now, why did I say that it is analogous to gravitational force? It is analogous to gravitational force because gravitational force ಅಲ್ಲಿ ಏನು ಬರುತ್ತೆ, gravitational law ಏನು ಬರುತ್ತೆ, F is G m1 m2 by r square. Here it is K q1 q2 by r square. Here it is directly proportional to the product of charges, inversely proportional to r square. Ali directly proportional to m square, inversely proportional to r square. Mass only ಒಂದೇ type ಇರೋದ್ರಿಂದ mass is always, gravitational force is always attractive force, whereas charges are two types, positive and negative. Therefore electrostatic force also is two types, attractive force as well as repulsive force. Attractive force ಎರಡು ಸೇಮ್ ಇದ್ದಾಗ attractive force ಯಾವಾಗ ಎರಡು different. Now in gravitation we saw if you have objects in air, in space or in any other different medium, if you take them and dip it in water or mercury or any other medium, what happens is the gravitational force between them does not depend on medium, whereas if you take charges and if you calculate what is the electrostatic force between the charges, it is actually different in different medium. Okay. Now the last point here, the force between any two charges is not affected by the presence of any other charge in the vicinity. ಇದನ್ನ ನಾವು ಗ್ರಾವಿಟೇಷನಲ್ಲೂ ಕಲ್ತಿದ್ವಿ, ಇದಕ್ಕೇನೋ ಅಂತ ಕರಿತೀವಿ principle of something principle of superposition, right? We learned that something called the principle of superposition, right? The principle of superposition ಏನು ಹೇಳುತ್ತೆ, if you want to calculate force between 3 or 4 or 5 or multiple charges or multiple objects, gravitational force calculate ಮಾಡೋದು. If you have two objects, let's say m1 and m2, divided another force F ಇದೆ. Now if you introduce m3, the force between these two m1 and m2, F in the change ಆಗಂಗಿಲ್ಲ, unless and until you change m1 and m2 or you change the distance between m1 and m2, the force F between m1 and m2 will remain same whether this m3 is present or absent. So similar to that, here also what happens is if you have q1, if the force of attraction and repulsion between them is, let's say, F, and if you introduce any other charge, q3, q4, any other charges, the force between q1 and q2 will remain same despite q3 and q4 being in the vicinity. ಈ F ಚೇಂಜ್ ಆಗಬೇಕು ಅಂದ್ರೆ ಏನು ಚೇಂಜ್ ಮಾಡಬಹುದು, ಡಿಸ್ಟೆನ್ಸ್ ಚೇಂಜ್ ಮಾಡ್ರಿ ಅಥವಾ q1 q2 ಚೇಂಜ್ ಮಾಡ್ರಿ, you change the medium. Gravitational force ಅಲ್ಲಿ mass change ಮಾಡ್ರಿ, distance change ಮಾಡ್ರಿ, change ಆಗ್ತಾ ಇದೆ. Here charges change ಮಾಡಿದ್ರು change ಆಗುತ್ತೆ, distance change ಮಾಡಿದ್ರು change ಆಗುತ್ತೆ, and then medium change ಮಾಡಿದ್ರು ಕೂಡ change ಆಗುತ್ತೆ. Right? There are three conditions in which the force between them will change. Change the charges, change the distance, or change the medium. Finished? Okay, we learn concepts only once or maximum 2 times. Later on, we will be focusing on applications a lot. Okay, please try and read these, revise these on your own as many times as possible. Now, electrostatic force is a conservative force. Since this is a conservative force, will we have electrostatic potential energy? Yes or no? Yes. Potential energy ಬೇಕು ಅಂದ್ರೆ ಏನು ಬೇಕು? If you want potential energy, compulsory you need what? Conservative force. So since electrostatic force is a conservative force, because of this electrostatic force, what will we have? We will also have potential energy. ಆ potential energy ಹೆಂಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ಅನ್ನೋದು ಒಂದು ನೆಕ್ಸ್ಟ್ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ. As I said, you can change the force between two charges by changing the medium. So how do you calculate the force when you change the medium? Is have something called as permittivity of medium. Permittivity of medium is represented as epsilon. Okay, is represented as epsilon. What is this permittivity of a medium? If you have any two charges, ಅವೆರಡು ಚಾರ್ಜ್ ನಡುವೆ ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಫೋರ್ಸ್ ಎಷ್ಟು ಇರಬಹುದು ಅಂತ ಮೀಡಿಯಂ ಪರ್ಮಿಟ್ ಮಾಡುತ್ತೆ. ಓಕೆ, ಬಿಕಾಸ್ ವೈ ಡಸ್ ಮೀಡಿಯಂ play important role is because the reason for electrostatic force is different. There are some subatomic particles which are responsible for electrostatic force. ಅವೇನಾಗುತ್ತೆ ಅಂದ್ರೆ ಒಂದು ಪಾರ್ಟಿಕಲ್ ಇಂದ ಇನ್ನೊಂದು ಪಾರ್ಟಿಕಲ್ ಇನ್ನೊಂದು ಪಾರ್ಟಿಕಲ್ ಇಂದ ಒಂದು ಪಾರ್ಟಿಕಲ್ ಎಕ್ಸ್ಚೇಂಜ್ ಆಗ್ತಾ ಇರುತ್ತೆ. Okay, the rate at which they are getting exchanged, okay, so that again depends upon the medium in which these charges are placed. Okay, please write this down. The property of the medium which influences the force between the charges is known as permittivity of the how much you talk or how sincere are you about doing your homework, how it depends upon the teacher and the strictness. Similar to that, force between any two charge depends on which medium they are placed in. ಯಾಕಂದ್ರೆ ಮೀಡಿಯಂ ಪರ್ಮಿಷನ್ ಕೊಡುತ್ತೆ ನೀನು ಎಷ್ಟು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಬಹುದು, ಎಷ್ಟು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಬಹುದು. In modern physics, you have a chapter called as atoms and nuclei and all. Okay, so there you study what is there within the atoms, what is there within the nucleus. In that, a little bit in depth we'll go and we'll try and understand. There are something called as quarks and gluons and mesons and fermions and all those things, where some of them are responsible for creating mass in the matter, some of them are responsible for creating fundamental forces. This is denoted by okay. So now, how do you write force between any two charges Q1 and Q2? Force between any two charges Q1 and Q2 is written as 1 by 4 pi epsilon so force is what? Force is actually inversely proportional to permittivity of the medium. Okay. So for medium 1, let's say the permittivity is epsilon 1, and for medium 2 the permittivity is epsilon 2. So how do you write F1? What is F1? F1 is force in medium 1. So force in medium 1 ಯಾವ ತರ ಬರೀತೀರಾ? 1 by 4 pi epsilon 1 Q1 Q2 divided by R square. ಅದೇ ರೀತಿ force in medium 2 ಯಾವ ತರ ಬರೀತೀರಾ? How do you write force in medium 2? You write it as 1 by 4 pi epsilon 2 Q1 Q2 divided by Now let's say the charges are same in medium 1 and medium 2. That is, they are Q1 and Q2 only, and the distance between them R is also same in both the mediums. Then ಎರಡು ratio ತಗೊಂಡ್ರೆ ಏನು ಬರುತ್ತೆ, right? If Q1 and Q2 are same and so is R, then can I write F1 divided by F2 is equal to, not E, it is epsilon 2 by epsilon 1 or epsilon 1 by epsilon 2? Right? In words, how do you write this? Force in medium 1 divided by force in medium 2 is equal to permittivity of medium 2 divided by permittivity of medium 1. Okay. This is an important formula, please remember this. What is the relative density? Density of specific gravity in chemistry. Yes, specific gravity, a specific density. What is it? It is density of any liquid with respect to water. With respect to density of water. What is specific gravity? Density with respect to water, with respect to hydrogen. What? With respect to water. So relative anta andaga it is density of that divided by density with respect to something else. Here also we have something called as relative permittivity. Relative permittivity is permittivity of the medium divided by permittivity of air. Here we take it as permittivity of air. The density of water and we take it as air. We'll talk about relative permittivity in the next class.